Hello, everyone. So today we are moving into day 2 of our substitution. So if you haven't already, or you weren't in the Google Meet, go make sure that you watch the day 1 video for substitution, because now we're going to get into some more kind of a little bit more advanced problems with substitution. So the first thing that we want to talk about are we have a couple special cases. Just like we did when we were graphing, it's the same idea. Usually we're going to graph we have one equation and then another equation. It's not a very good drawing, I apologize. And we have one spot where they intersect. But there's 2 other scenarios that could happen. We could have 2 parallel lines that never intersect, or we could draw one line and then draw the next line, and then we realize, oh, this is the same line. And so every single point on that line is a solution. So remember, that's infinitely many solutions, and when you have no intersection, that's no solution. So sometimes this can happen even when we just have regular equations. Those equations represent those lines, so we can still have those things happen. So let's take a look at what that's going to look like. Let's go over here. We can see, okay, x is equal to 2y minus 4. So I know, okay, awesome, that's what I'm going to plug in for that x right there. So when I have 3x minus 6y is equal to 6. Okay, cool. I'm going to replace that with 3. Now I know that x is equal to 2y minus 4, so I'm going to plug that in because I know that's the same thing as x, 2y minus 4. And then I still have my 6y is equal to 6. Okay, so I'm going to distribute. So I have 6y, 3 times 2y is 6y, 3 times negative 4 is negative 12, minus 6y is equal to 6. All right, same as before. Now I have some terms that I can combine. So 6y and negative 6y, well, when I add those coefficients together, I have 0. So, I mean, I guess I could write 0y, but that's just really going to simplify out to nothing. I just am left, really, with negative 12 equal to negative 6. That's an alarm bell. Okay, check your math, make sure you didn't make a mistake. But when this happens, you should be thinking, oh, I have a special case here. When it looks like this, where it's not equal, negative 12 isn't equal to 6, that's going to be a no solution. This is one of these where we have 2 parallel lines that aren't intersecting with each other, right? So that's what happens when they're not equal. Let's take a look at one that is equal. Let's see what the difference is here. Okay, so I have y is equal to that 1/3 x plus 1. Let's see what happens when we plug in this y here in that equation. Okay, x minus 3y is equal to negative 3. I'm going to swap out that y with that 1/3 x plus 1. So x minus 3, 1/3 x plus 1. Oh, I meant to color code that. Okay. It's going to bother me now if I don't. Okay. So my y is 1/3 x plus 1. I replace that other value is equal to 3. All right, so I'm going to distribute here. It's a negative 3, so I know I have to distribute a negative 3. Okay, don't forget about your sign as you're distributing. Okay, so I get x is equal to, no, sorry, not equal to, x minus, because I have negative 3 times 1/3 x. Okay, negative 3 times 1/3 x. Let's turn this into a little fraction problem here. So, okay, negative 3 times 1 is negative 3. 1 times 3 is 3. That simplifies to -1. I've got a -1x, or just -x. It doesn't matter. It's the same thing. And then -3 times 1 is -3. It's all equal to -3. All right, so x minus x, I can combine those like terms, and again, they zero each other out. They cancel each other out. X minus x is just 0. So I'm left here with -3 is equal to -3. And that's true. When you get just number equals a number and you've totally eliminated your variable, that's another way to know, oh, okay, I have my special case, except this one, instead of no solution, it's infinitely many solutions. Okay? So when it's not true, it's no solution. When it is true, it's infinitely many because it's all really just the same line. Okay? So that's how you kind of know. When I get to the end, I've eliminated a variable and it's just 2 numbers. That's when I know it's a special case. We don't have to go back like we had to the other day and plug in, oh, this is my x value, so let me plug it in and find y. There's no value to plug in, so you don't have to worry about this step if you do have a special case. Right? So here, this is all kind of saying the same thing. When you are solving and both of your variables cancel out, there are 2 different things that are possible. If you get a untrue statement, like 8 equals 0 or -10 equals 4, that means there is no solution because it's not true. Okay, that's when you have your 2 parallel lines. Okay, if you get something like 5 equals 5, or what we just had, -3 equals -3, that's true, so there are infinitely many solutions. Okay? It's the same line, so every single possible point on that line is a solution to both. Right? I am going to give you guys a chance. I'm going to solve this on my own, but I'm not going to walk you through step by step. If you want to pause, you can see if you get what I get. All right, so hopefully we ended up with the same answers here. If not, maybe go through. Again, you can pause and see if you can find where we have different work. Okay, now let's keep going. Sometimes we are not going to have our system set up like we have just right here, where we have x equals something or y equals something. We're going to have to kind of shuffle some things around in order to get to that point, right? So in order for us to do that, the easiest way for us to do that is first try and pick out, okay, see if you can find variables that don't have coefficients. Okay, as I'm looking through, I'm trying to find these variables that don't have coefficients. It's even better if it's not a negative, but if it has a negative, that's not too hard to fix. Okay, because basically what we're going to have to do here is reorder some of this stuff. So I'm going to reorder everything before I solve any of these problems. Okay, so I'm going to start first at A, because before I do anything else, I want the format of this equation to look like what we've seen before, where it's just x equals something or just y equals something. So I've identified, okay, this is the only variable I have with no coefficient, so I'm going to stick with that. I want to get just x on its own. Okay, so in order to do that, I'm going to need to move this -4y. So to do that, I need to add 4y here to both sides. So I get x is equal to 4y minus 1. Now that looks like a problem that I'm used to seeing. That's something that I can go in and solve. Okay, same thing over here. Well, I've got a y and I've got a -y. Positive y is going to be easier because all I need to do is move that 3x to the other side and I'm good to go. With this one, I'd have to move the 2x and then I'd have to change the sign. So let's do this. I'm going to subtract 3x from both sides. That's a little hard to see. I'm going to rewrite this. Okay, so I've got 3x plus y is equal to 5. I'm going to subtract that 3x from each side. I'm going to be left with y is equal to negative 3x plus 5. Okay, there's that little chunk we can use to substitute. C is a little bit trickier because we have this little x that doesn't have a coefficient, but it does have a negative sign. Okay, so when we do that, we have one extra step at the end where we need to go through and change the sign of everything. So I can say, okay, negative x plus 2y equal to 3. I can move that 2y, not 2x. I can move that 2y over. Okay, subtract it from both sides. I get negative x is equal to negative 2y plus 3. I don't want that negative in front of the x. I have to divide out that negative 1. So I get just positive x. I get positive 2y, negative 3. I essentially just change the sign of every term in my equation. Now I have x equals something, and now that's good enough. All right. I think I'm just going to do 2 of these because this video is already getting a little bit long. I know these problems are super long, so let's just do A and B. All right, so A, same as before. I have this little 4y minus 1. I know that is the same thing as x. You can't plug it back into this equation. That was the equation you just moved around. You have to plug it into the other equation. Okay, so I'm saying, okay, 2x plus 2y is equal to 3. And I know that, okay, x is this 4y minus 1, so I'm going to swap that out. I have 2 times 4y minus 1 plus 2y equal to 3. Okay, and then the same steps as we're used to. I'm going to distribute. 2 times 4y, I get 8y. 2 times negative 1, I get negative 2. Plus 2y equals 3. Now I combine my like terms, 8y and 2y. I get 10y. Still have that negative 2 equals 3. I'm going to add 2 to both sides. Running out of room. So I have 10y is equal to 5. I am multiplying by 10, so I'm going to divide by 10. And I get y is equal to 1/2. Okay, oh, and I almost did the mistake I always tell you not to do. You're not done. You're halfway there. Y is half of your answer. You also have to find your x. Okay, so you have to go back. You can use, usually this version of that equation is easiest because you can just plug it in and you see right there what the number is. So I'm going to plug it into x equals 4y minus 1. I could plug it in to this equation. I could plug it into this this x minus 4y equals negative 1. I could plug it into, it doesn't matter which equation I plug it into, but this one looks like the easiest one. Okay, so what did I decide? It's it's 1/2, not negative 1/2. And the x is equal to 4 times x. Sorry, 4 times y. I'm mixing myself up now. It's x equals 4y minus 1. My y value is 1/2, so it's 4 times 1/2 minus 1. X is 2 minus 1, so I have positive 1. Your answer is always that xy, so my x is 1, y is 1/2. That's your final answer there. Okay, now we are going to do the same thing with B, and then I'm going to call it a day. I know these problems are kind of long. We've had a bunch of examples. All right, so we've already kind of moved it around because I was showing you how to move those equations and reorder them so that they work for you. So I see this y is equal to negative 3x plus 5. So I'm going to say, okay, I know I need to plug it into the other equation, into 2x minus y. is equal to 10. Okay, so now I'm going to plug in my little y. I know y is the same thing as negative 3x plus 5. And that's all equal to 10 still. I'm going to distribute just like always. Okay, and negative I can think of as negative 1. So now I have 2x plus 3x. Okay, negative 1 times negative 3x, I get positive 3x. And then negative 1 times 5, I get negative 5. Still all equal to 10. Okay, 2x plus 3x is 5x. I combine my like terms. I have 5x minus 5 is equal to 10. I want to get rid of that 5, so I'm going to add it to both sides. Okay, it's a negative 5, so I'm adding 5 to both sides. I get 5x is equal to 15. Okay, I'm going to divide out the 5. I'm multiplying in the original, so I'm going to divide. And I end up here with x is equal to 3. Okay, I'm halfway there. I have my x value. I know it always seems like, oh, I can't believe I have to do more after all that, but usually it's pretty quick to plug it in. Okay, I'm going to go right over here. Y is equal to negative 3x plus 5. Let's go ahead and plug it in. We want to find our y value. Okay, negative 3 times x, which is positive 3, plus 5. Okay, y is equal to negative 9 plus 5. And then y is now equal to negative 4. Okay, it's always x then y, so 3, negative 4. Okay, so now you know how to do these problems where you have to rearrange a little bit. Go ahead and look at today's folder. You can see the homework. Make sure you look at the page to see the due date. The schedule has been up in the air as of when I'm recording this video, so I'm not sure what day it's due. So just make sure you're checking Schoology, getting all your missing assignments done, making sure you're caught up, and then very soon we should be coming back to hybrid, and I'm so excited to see you guys. All right, talk to you guys later.